All right, welcome to This Explainer. Look, if you are a technical professional, a developer, or a systems designer looking to finally move past the basics of generative AI, you are in the exact right place. Today, we're putting aside all the basic beginner tips and stepping right into a premium masterclass on intelligence architecture. We are going to break down the definitive blueprint for mastering AI prompt engineering, and we're drawing this straight from elite frameworks and technical white papers.
Okay, let's dive into this. The stakes here are incredibly high, and honestly, it all boils down to one fundamental reality. We have got to fundamentally reframe how we think about large language models. You see, AI doesn't think the way a human brain does. Actually, scratch that. It doesn't really think at all. It is, at its core, a highly advanced prediction engine. It relies entirely on patterns, probability, and context mapping. If you feed it a garbage, unstructured prompt, it literally has no choice but to predict a generic average output. But if you provide a highly structured prompt, you're handing the engine the exact architecture it needs to produce expert-level, highly specific work. Basically, the quality of what you get out is entirely dependent on the quality of the architecture you put in.
And this brings us to the absolute core mindset shift. Casual users treat AI like a search engine, right? They just ask it questions. But asking questions is a really weak approach because it forces the AI to guess all your hidden expectations. Elite users, the intelligence architects, they don't just ask questions. They architect intelligence by designing explicit cognitive workflows. Whenever you just throw a simple, zero-shot question at an LLM, you should treat it like you're throwing raw, uncompiled code at a server. I mean, sure, it might run, but you have zero control over how it executes. Real quick, here is our roadmap for the explainer today. 1. Architecting AI intelligence. 2. The universal prompt formula. 3. Persona and output engineering. 4. Advanced AI reasoning. And finally, 5. The React agent framework. Let's start right in with Section 1, Architecting AI intelligence and the mechanics of prediction. Here is the absolute golden law of prompting. Never assume AI knows what you want. An AI cannot reliably infer your business intent, it doesn't know your formatting standards, and it certainly can't guess the emotional tone you're going for. You have to explicitly architect those boundaries. And we do this mechanically, too. Behind the scenes, we're controlling this prediction engine using parameters like temperature, which dictates the randomness of token selection. A temperature of 0 gives you highly deterministic factual output, while a higher temperature dials up the creativity. We also use top K and top P sampling to restrict the AI's vocabulary down to only the most probable logical tokens. Now, once we've set those mechanical constraints, we've got to establish our linguistic constraints. Which brings us to Section 2, the universal prompt formula, our master structure. So the crucial point is that a truly robust prompt is built just like a load-bearing wall. It requires all of these 7 layers of AI response generation. You must define the role the AI is playing, the background context, the specific objective, the exact constraints or rules, the required output format, the quality control standards, and finally, the optimization or the final execution command. The white papers are incredibly clear on this. If you are missing even one of these layers, your output quality drops massively. Why? Because the AI just lost a critical piece of its prediction mapping. Moving right along to Section 3, let's look at persona and output engineering and how we actually steer the model's behavior. Listen, giving an AI a specific expert identity is arguably the single biggest improvement you can make to your prompts right off the bat, because it activates specific knowledge patterns buried in the model's training data. But we can take this a huge step further with a technique called persona stacking. This is where we combine multiple expert identities to activate layered, highly specialized intelligence. And this brilliantly illustrates what I mean. In practice, persona stacking completely changes the game. Instead of just saying, hey, act as a marketer, an elite intelligence architect will stack the identities. You tell the model to act as a Stanford behavioral psychologist combined with a Fortune 500 marketing strategist, a viral social media expert, and a storytelling copywriter. By combining these, you completely alter the mathematical probability of the words the AI is going to select, essentially forcing it into a highly specialized elite cognitive lane.
Right, and once you have the persona locked in, you must strictly control the output. You should never, ever just ask for any format. There's a stark contrast between intents here. If you want an executive breakdown, you strictly prompt for a summary, insights, recommendations, and risks. If you want a technical format, you force the AI to output architecture, components, workflow, and security. Structuring the output doesn't just make it look pretty on the page. Constraining the format actually limits the model's ability to wander off topic and dramatically reduces AI hallucinations.
Now let's escalate the complexity. Section 4. Advanced AI Reasoning and Building a Logic Engine. Standard prompting relies on something called greedy decoding, which means the model just predicts the next most likely word in a single linear path. Honestly, this is terrible for complex logic. To fix this, we use chain of thought, or COT. This is the practice of explicitly forcing the AI to think step by step and generate intermediate reasoning before it produces a final answer. It is such a low-effort prompt addition, but it serves as a foundational logic engine that forces the AI to actively validate its own work.
Let's look at his super concrete math example from the white papers to show you what I mean. Picture this riddle. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? If you just ask this zero shot, the model will often spit out a completely wrong number, like 63 or something, just blindly guessing the relationship. But with chain of thought, it breaks it down logically. It realizes the partner was 9, meaning the age difference is 6 years. It applies that 6-year difference to your current age of 20 and accurately concludes the partner is 26. Standard prompting fails at simple logic. Chain of thought completely nails it.
But we can push this logic engine even further. We know greedy decoding is a single error-prone path, right? Well, with a technique called self-consistency prompting, we force the AI to generate multiple different reasoning paths, usually using a slightly higher temperature, and then we use majority voting to select the most consistent answer. Think of it exactly like redundant server checks in a data center. You're basically asking the system to calculate the answer 3 or 4 different ways, and if the majority of those separate paths lead to the exact same conclusion, boom, you have incredible